If you'll recall, vertebral arteries are the secondary route that blood can actually be transported to the brain. The internal carotid artery was the primary route. Now, both vertebral arteries are going to come together and form basilar artery. Now, we got quite a few more here, but all of these arteries actually come together and they make almost like a stick-looking Ant-Man from an inferior view of the brain here. So vertebral arteries, we have a left and a right. They will come together and form the legs. So we'll put a V for vertebral. Basilar artery will come together and form the torso. So again, we have two vertebral arteries here, coming together and forming basilar artery. Now the arms of our stick figure are called posterior cerebral artery that go to the backside of the cerebral. So we'll say posterior cerebral, PC. Now we also have something called posterior communicating artery. And they're going to form the face. And unfortunately, our stick figure doesn't have much of a neck here. Now, just to keep reference, we're going to draw on the internal carotid arteries. And they're going to be cut right here. And they almost form weird-looking sunglasses on our stick figure. Those are internal carotid arteries. So I'm going to put a number 1 here and write that somewhere else. That way we know where these are. So internal carotid artery. We'll annotate that number 1. Now our stick figure is also going to have some pretty long ears. These are the middle cerebral arteries. MC. Now our anterior cerebral arteries are going to form the horns and the top of his head. They're going to go up just like so. They're called anterior cerebral arteries. So there's 2 of them. We'll call that AC for anterior cerebral. Now this really tiny one that connects the 2 anterior cerebral and completes the head is called anterior communicating. So let's fill in the rest here. We're going to make an arrow, put a number 2. Again, remember there are 2 posterior communicatings. And then anterior communicating, I'm going to use a blue arrow. And again, this has nothing to do with the veins, this blue I'm doing, just to make a good contrast for our arrow. So everything's not just red. There, we'll put a number 3 for anterior communicating. Now this is the basis of the circle of Willis, which is going to be circulating the hypophyseal stalk, which is what connects the pituitary gland to the actual brain here. And so you can imagine if we had a clot form in this internal carotid artery, this side of the brain would no longer be getting blood. Well, our body has developed a system called the circle of Willis that allows blood to be pumped to the other side, either through the internal carotid arteries or through the alternate route of the vertebral arteries and basilar arteries going to that side. That's what the circle of Willis is. So taking a look here, a more realistic picture, here are those vertebral arteries right here forming the legs. The torso is the basilar artery. The arms, going back here, are the posterior cerebral arteries. Forming the face right here, the posterior communicating arteries. We have the internal carotid arteries on either side. Continuing on there is the middle cerebral arteries. The anterior cerebral arteries that come up, they actually dive into that longitudinal fissure on either side. And then this small little branch connecting the 2 is the anterior communicating artery. We also have to start on the veins of the brain.